In this video, we're going to solve simultaneous equations using graphical and algebraic methods. We get simultaneous equations when two conditions must be met at the same time. For example, the two conditions can be represented by these two equations. We'll solve this graphically by drawing the two lines. The first line is drawn using the two intercepts, and similarly the second line has been drawn using the x and y intercepts as well. We can find the intersection by reading it off the graph, and there it is there, and we can't read that off any more accurately than about 2.2 with minus 0.5. Algebraic methods have two advantages. They lead to an exact solution, and they can be used to program a computer to find a solution. There are two methods that can be used, substitution and elimination. And in both methods, the technique is to solve for one variable first and then use that value to find the value of the other variable. Let's have a look at substitution firstly. And this can be used when one variable can be expressed in terms of the other variable. For example, if you have the equation y equals 2x plus 1, you can substitute for y in the second equation, which is exactly what we've done here. Instead of y in the second equation, we will substitute 2x plus 1. We then expand that bracket out and collect our x terms and then solve for x. X equals 1. We can now substitute x equals 1 in the first equation to find y. So instead of x, now we'll write 1 and then find what y is. That gives us y equals 3. So our overall solution is x equals 1 and y equals 3, which can be written as an ordered pair 1, 3. Always finish off by writing down what the values of both x and y are. And it is very important to explain what you're doing as you go through, otherwise it's very difficult to follow what is going on. Sometimes we may have to rearrange one equation to make either x or y the subject before we can substitute into the other equation. So for example, if the first equation was given as 2x minus y plus 1 equals 0, we can easily rewrite that as y equals 2x plus 1 and then proceed as we have done previously. The second method is elimination. And we use this when we can eliminate one of the variables by adding or subtracting the two equations, which may involve multiplying one or both of the equations by some number to get a common term. Once again, it's important to show your reasoning, otherwise it's hard to follow what's going on. And a good technique is to number the equations and to state what you are doing to these equations. Let's revisit that first example. The two equations are given here. We need to get a common multiple of either x or y, and then add or subtract the equations to eliminate one of those variables. In this case, we're going to get a common multiple of 6y. So to get 6y, we need to multiply that first equation, which we've labelled as 1, by 3. We'll write that down as 3 times equation 1, so we'll get 15x plus 6y equals 30. Similarly with the second equation, we need to multiply that by 2, and we can see now that we've got 6y and minus 6y. Adding those two equations will eliminate y, hence the name elimination method. So now we've got 19x, when we're adding the equations, is equal to 42. So we can find x from there as 42 over 19. To find y, we substitute that value into either of the first two equations there. We'll use equation 1 in our case. X has now been substituted by 42 over 19. Notice that we use the exact value there, not the approximation 2.21. We can now solve that equation. what we've done here is multiply 5 times 42 to get 210 over 19, which we've subtracted from both sides, and the 10 we've expressed as 190 over 19. We now need to divide that equation by 2, and we'll get an exact value of minus 10 over 19, which we can approximate with a decimal. So the solution is x equals 42 on 19 and y equals negative 10 on 19. The graphical solution we obtained earlier was not as accurate as this. So in this video we've seen how we can solve simultaneous equations graphically and by substitution or elimination.